Takže vážení priatelia krásneho slova, literatúry a umenia a všetkého príbuzného, dovolte mi poďakovať na úvod majiteľovi Artfóra, pánu Ničíkovi, že nás mohol tu privítať toto sobotnejšie popoludnie. A my sme tu prišli dnes so vzácnym hosťom, pánom hostujúcim profesorom Andreom Segalinym z Parmy, ktorý aktuálne pôsobí na stavebnej fakulte Žilinskej univerzity v Žiline a dnes budem ako keby klásť otázky ja, pretože naša naplánovaná debata je trošku odborná a trošku taká aktuálna, naväzujúca na predošlú diskusiu v Artfóre, kde vystúpil pán profesor Moravčík s témou padajúce mosty. Takže prejdem plynule aj do angličtiny, takže ja sa volám Marian Drusa a som dekan stavebnej fakulty Žilinskej univerzity v Žiline. No a prejdeme teraz do iného jazyka, pretože aby náš host mohol s nami plynule diskutovať. Ladies and gentlemen, dear guests, dear friends of arts and literature, I am pleased to introduce Professor Andrea Segalini, which is actually a visiting professor of University of Žilina. And this afternoon we will speak about structural health monitoring, early warning system, and like a new development and new futures for research in this field. We know that this topic is so demanded actually because we have a lot of damages and we want to continue with previous talking about falling bridges, which happened in not only in Europe, but in the world, and bridges are important to connect people for a better living. So, Andrea Segalini is here, and he is ready. Yeah, good afternoon. And my first question is, what is it structural health monitoring? How it is important to develop in the country?
Well, I believe that structural health monitoring is something that we found needed in this last decades because we actually found out that our structure are going through a phase of decay during the time, and this decay is caused by many reasons. Probably most of it is due by the meteorological adversity, but also about the increasing traffic and the increasing use and the changing traffic in the world, and especially in our civilized country, we have very much progressed this changing in traffic. So, health structural monitoring is something that is, in few words, it will be the possibility of embedding some instrumentation that with the help of the electronics we would help us to understand how the structure is behaving and how the structure is modifying its behavior during time. This could be done either for civil structure but also for geotechnical structure, like for instance for underground constructions and for protection work for like landslides or any kind of other potential natural damage or difficulties in this problem. So that's more of it.
Yeah. So I can confirm that Professor Segalini is a very good expert in this field, and he is owner of world patent for a unique monitoring system of underground movement measurements. So we have nice cooperation, and I can say that the future is more monitor, to have a more information, more security, and in order to have a time to predict something. So which is not easy. We can say if there is some landslide probability, and we have like a precipitation time, like 2 weeks of heavy rainfall, we can be worried about some stability, some flooding event, some possible damages. So this topic is really demanded, I think, this time, because changes in the weather through the Europe and world are significant. So can you say how you started, in which time you started deal about monitoring?
Well, I actually started to be interested in monitoring since the beginning, because being from geotechnical field like you are, we have the need to understand how our instruments of work, which are soils or rocks, are actually performing, and how their mechanical behavior is affecting us in terms of our structure or our designs. And this is a little more difficult than the structural colleagues, because the structural colleagues usually have to deal with some kind of element or material that are actually made by them on their needs, so they can make a different type of iron, a different type of cement or concrete, and they can adjust the materials to their needs. For us, it's very difficult to do that, because we deal mostly with natural materials, so we need to understand how the natural materials are behaving under the stress that we impose to them with the structure or with some kind of modifications, like cutting for roads, like heavy embankments, and so on. So we started back in like 15 years ago, I would say 20 years ago, to think about this. We actually had some old-fashioned monitoring systems that require the presence of the man, of the people, in order to actually make the measures. So we had a very sporadic, a very relatively not very frequent, I would say, not very frequent measures for displacement, for instance, for landslide, or for increasing of water level during the precipitation or during some specific flooding event. And due to this, we actually found out that having a low frequency monitoring is not enough to understand the behavior, or at least to be able to predict the behavior of some natural event. And this is very important, for us. And that's why we went into this system thinking about and trying to take advantage of the new technologies, especially those that came out with the mechanical industry, especially the car industry or the telephone and all the electronics. They favor us much because they produce sensors that are very cheap, and they can be produced in large number, and then very easily connected. They can be very easily connected because they use digital connection instead of mechanical connection, or so. That was when we started to do this, and then in the years we developed even more interesting about this subject, and we actually, and unfortunately, have seen that some recent structural collapses could have been actually, I'm not saying they could be avoided, but they could have been at least precursed, and we could have put on some early warning system on the structure as well. So that's
So, but when we turn back a little bit for history, we can say that peoples must learn from biggest damages and events, and after that they start to be interesting in this topic. This is true that sometimes our topics, which we many times proposed, is not supported by grant, or some it was not properly listened That's a problem, and therefore why we are here today, because we want to comment some history, and we can predict some future events. So in Slovakia we had a heavy landslide in Handlová, which almost damaged 15 houses, and also there was a large landslide in Riečnica in 1963, and many other events.
Mhm.
But in Italy, I know there was like a tsunami wall in Vajont water dam, and there was almost killed a lot of
2,000 people,
2,000 people
Yes.
in Longarone city.
Exactly.
Below water
Exactly.
dam. So this is history of engineering geology, which is strongly related with monitoring, because not even structure must be monitored, but also rock environment must be monitored.
Yes, it is very important to monitor the environment, because around us we are anomalous engineers, because we are engineers that try to understand with mathematics the behavior of natural materials. Natural materials don't behave according to maths, but we can we are trying to find some rules in order to understand them and be able to deal with them in mathematical terms. In order to do this, we need to build up good knowledge of what is the actually behavior of the natural materials, induced mainly by the variation of the meteorology, variation of the other natural events around it. And like we do with the design of bridges in order to the hydrogeology or hydrology of the region, we look how much rain is coming, we look how much the rivers are growing, and then we define some levels at which we have to build our levee or we have to build our bridge in order not to be affected by the possibly floods. At the same things we should do with landslide or with some other recursive natural event. Unfortunately, it's much easier to measure, or it was in the past too, much easier to measure raining or to measure the level of a river, because somebody was always there and could always put it on a book. We have a history of 200 years of observation of the Po River in Italy, for instance, and every day they wrote on the book which was the level of the river and how much rain came in the day before or in the hours also. Nowadays we have automatic instruments that do that, but thanks to this observation we are able to formulate some prediction of what it will be, and we are able to understand with the statistic elaboration, which are mathematical elaboration of what happened in the past, we can define our critical level, and we can define our return time for some of the events. This was done for hydrogeology, for river, and for bridges, and for levees, for structure that control the floods, but it was never done in the past in a systematic manner for landslides, for instance, or not even for or during the construction of some specific geotechnical structures like tunnels. Tunnels is very difficult. It's very difficult subject to deal with, not so much for the geometry of the tunnel, but for the understanding of the behavior of the tunnel itself, but for the understanding of the behavior of the material that is around it. Because if we imagine that we drill a tunnel to cross the Alps and we are below 2,000 and 3,000 meters below the ground level, we cannot possibly investigate the place where the tunnel will cross through before we actually get there. We can have some I would say, some prediction in general terms thanks to the analysis of the geologists, but we cannot really understand and know what we will find there. And the progress in the construction has also been made possible by the measurement that they were taking during the construction of these tunnels. In the beginning, constructing a tunnel was a very risky operation for the people that were working there. Many men were dying in this operation, and there are still some historical beliefs especially in Italy and in the mining industry, there are beliefs about the trust in some specific saint, like Santa Barbara is one of the protector of the miners, and this was because this activity was very risky for the people that were actually making it. And now we're trying to improve in this, have much less accident, possibly none, and we try to understand, we try to collect information from what we do, what we actually build in the territory, so we can maybe be better in the future and be more safe, either for the constructors and for those people that are working to make the tunnels, but also for the people that in the future or during the lifetime of the construction, they will use it and they will actually work on it, will drive on it, to say.
Yes, yes. So you mentioned that previously it was measured, it was controlled, but not systematically, just if there was some prediction of bad development. I can say that also in our important structure we have a monitoring, but it's not active and not as can be in the 21st century. So this is still very big place for improvement and development, which thanks to you and your research and your company, spin-off company of University of Parma, developed like a new inclinometer and,
yes.
and any other new measurement systems for complex monitoring of important part of infrastructure and also rock environment. Can you say just briefly about your success in this field?
Yes, well, what we tried to do was actually to build some instrument that was cheap enough to be accepted by the construction company and to be accepted also by the contractors, because the problem with the monitoring is that it was always something that it was something put in place as a plus for the construction. They don't really like to have monitoring on it, mostly because monitoring costs money. But it's always very cheap compared to the cost of the construction. But you know that the construction company and also contractors, they try very much to save money during the construction. So this is the additional cost that it could be, if it could be avoided, yes, it was going to be. And this one was one of the reasons that brought me to, actually was, the main reason was for research scopuses that I had, because I could never find information about what happened during the landslide, or at least immediately before it. Normally, what we did, there was a landslide, and we had many in Italy, not only the big one, but also the small one that can teach us very much. And we have many, like maybe 2,000, 3,000 landslides per year. So it's something that is very common. And when we go on a site, we see what happened during the landslide, and maybe there was some instrumentation there, but there were some instrumentation that were manually read or assessed by people, and just before the landslide, nobody went there. Also because normally landslide occur when the weather is bad, when you less suspect them in terms of measurement.
Yes.
So I felt the need, in order to understand better what was going to happen before the landslide actually started or was activated, I felt that there was the need to have some instrumentation there to be able, that was able to read regularly, automatically, with the use of a small computer or some specific data logger, which is not very expensive, and collect A lot of data. Many of these data are not useful to anybody because they just stable and they don't tell you anything, no modification. But at the moment, or the few days or few hours before the landslide actually activate, we can collect many information that let us know if the water level increased, if the movement were regular or if they occur in some specific occasion. We can associate the movement with, for instance, earthquakes. Italy is a very active earthquake country, and sometimes many of the landslides, especially those that occurring in rock masses, are triggered by those events. But if you don't monitor it constantly, you will never be able to understand and put the right connection between what's happening and what caused it. And our main object of our research is that understanding the causes, because if we understand the causes, then we can do something about it. And this is the way we developed. Then we started the research, and then the research was kind of interesting. We found some instrument that was performing well and was quite cheap, and then we started a spin-off of the university, and we started to produce these inclinometers for measuring the formation of the landslides. Starting from this and listening to the requirements, or maybe there were only some kind of desires from the contractors, especially those that they have the burden of controlling the roadways, the railways, and so on. So mostly state company, they provide us some input in order to better develop the sensors, or better, let's say, target the sensor in the right way that could be useful for them. And so we started to work, and I had some PhD students working on the subject and getting too in depth in this. And we started this small, I would say small company, still a small company, but is beginning to gain a good credibility on the Italian market, and we are also having some experiences abroad. We have one instrument here to be installed in the very next future to control one landslide. And also we went on to some other instrumentation that is useful for underground construction, and also for bridges. We have some other instruments that could be applied in that. So this is one of our topic. Then the second topic that it comes right away after this installation of the instrumentation is how to deal with the data. Because now we don't have only few data in 1 year. We have thousands of data that are coming into our machines, to our computers, to our servers. And then what? You have a lot of numbers. And okay, we are engineers, we like numbers, but not too much, not too much. And when we have this number, the problem is how to deal with them without losing too much time. Because if we need another person or two scientists that read all the numbers in order to get those that are significant, we will lose our objective, because we will have many people losing much time for nothing. So we need to learn to teach, to teach the machines, or even better, to have the machine learn by themselves what is happening. And in this self-learning process, they will understand and they will start to tell us when something is modifying in the course of actions, and when we need to pay attention on it. Machine will not solve our problem from the engineering point of view, from the geotechnical point of view, from the geological point of view, but they will help us understand that there is a problem promptly. And this is something that is very important, especially for when we want to build some early warning systems, when we want to build something that can inform the population that something might happen in a short amount of time. We need sensor to measure. We need some, let's say, elaboration of the data, automated elaboration of data. And also we need somebody who can be called to evaluate the elaboration and decide the decision. The decision making is always the most difficult task that has to be done. And unfortunately, it needs to be done by people. Yeah. I'm saying unfortunately because, of course, it's a big responsibility to have the choice to say yes, no, stop, go. It's a very big responsibility. A few days ago, we had a big tragedy in Italy.
Mountain, yeah.
Yeah, we had a cable car that was completely destroyed, and 18, 16, 17 people got killed in this accident. This is a very, I would say, strange things that still happen in 2021, because it's not imaginable that a mechanical system can fail like this when the life of people are on track, can fail like this without any safety that is put around. I'm not saying that monitoring could solve that, and I'm not saying either that there might be responsibility of peoples in that. Yeah. But it is very important that we are starting to use the machines, especially the computers, to tell us that something is wrong. Why is it important that we use the computer? Because the computer get the data, store the data, and they become testimony of what is going to happen, or what is happened, and what it will happen in the future. So it's like some kind of objective judge that is above you and tells you this is what happened, and it was before, and then something happened, and also can tell you, and you didn't anything about it, but you knew that was something happening, and you didn't anything about it. And then I'll let you give you the word because it was very long. But last thing I want to say is also that this is one of the problems of the monitoring, because not always people want to know what's happening. Yeah. Because knowing that means facing responsibility as well. And you cannot escape by that. If you have something recorded, then there might be something or someone who's responsible for it.
Yeah, I'm completely agree with your words, and they are very important. I can say that in Slovakia we use the early warning system for important hydrotechnical structures like nuclear power plants or water dams. But I think our role is to teach not only our students but also responsible people in other sector of industry and transport and living to implement early warning system also to infrastructure. We have only few important infrastructure objects which are permanently monitoring. So there is no permanent control of situation, and we just can do something when something went wrong. This is also an example of our very dangerous road of first class between Strečno and Dubná Skala. There was some remediation and some realization of protection work. There was some installation of dynamic barriers, but after tragical dead accident, which one falling block of rocks hit the car. So in the future, we have to be more clever, and we have to learn from history, and we can install new efficient system to many places where it is required. So, because I don't want to worry about traveling of my son, of my child. So we have to be in 21st century better informed. So our message of today's talking is that monitoring is important not only in nuclear power plant, which is highly important facility, but also in any other like an object of our living when we are in contact. So today is very popular IoT, like Internet of Things. Do you mean that it should be some step of improvement in these things?
I think so. Let's say, in order to defend our predecessors that didn't use so much the monitoring, I have to say that in the past, locating or installing monitoring systems that were mechanical systems, it was always a very costly operation. That since the economics is involved in everything in our lives, there was a reason why they weren't so much used, the monitoring. It was because they was very expensive. Nowadays, we have instrumentation that are very cheap compared to the structures and compared to what actually can be the cost of some damage, on the people and on the economic source of a region, of the industry, on the roads. It's much more cheaper to maintain a monitoring system on a bridge than to maintain the bridge itself. Much more cheaper. So why shouldn't we think about a construction that is, since from the beginning, is monitored and is controlled? This is something very important. And of course, then IoT or Internet of Things is something that came out in the recent years, and we almost all have in the house something that we can control with the power of our phone. We can start the heat, we can start the washing machine, we can start the TV even, or register programs or do things that are very simple, but that we understand they become our way of life, our comfort, in the house. And this comfort that we appreciate in the house, we can also put it with the use of monitoring system and sensor in the field of natural hazard. So that's why in one of my recent publications, I, let's say, use the terms Internet of Natural Hazard, IONH, because I think that we could do something properly in this field in order to improve the knowledge of the people and improve also the cultural preparedness of the population, because the population must know that we as engineers, we cannot design structures, especially for natural events, that will resist every type of occurrence. We have some that are most probable, and they have a higher probability, some that have less probability. But we cannot think that we built a structure that will be indestructible, because this is not possible. Whoever would have thought in the past that we would have assisted at the fall of the Twin Towers in New York? Nobody. But there was something there that was unexpected, because it was very, very, the probability of occurrence of that event was very, very little. But of course, it's not possible to avoid something like this completely. So the people has to learn that, or in general, the population, the users of the territory, of our facilities, of our civil construction, had to learn that this, we are working to improve constantly our knowledge, but we are still studying for everything, to get better, to be better prepared for the future and for the community. So that's, I think, is something that we should also pass on to the students or the potential students of the university in civil engineering and on environmental and territory and so on. That we do a service, a very important service. We will do a very important service for the population.
Yeah. I can just comment that this is really our message, which we can give our listeners, that it's much easier to have important parts of structures under control not only water dams and power plants, but
also
normal bridges which they serve connection for a daily 20,000 traffics, for instance, like in Žiline surroundings. And also we have to better maintain historical buildings and structures, and we can monitor also like humidity and other things, because also this is our part of treasure and our history. In Italy is country which I like because you can move through the city to city and you will find every nice history. So there is I can say that if you travel to Italy every month, you will find still new things to learn and new
to
things
see.
to discover and see. But morphology of Italy and Slovakia is quite similar.
Quite similar, yes.
We have Carpathian Mountains, you have Alps, and you have
Apennines.
And that's quite similar. That we have same problem, and we have to cooperate to push these things to better in future.
Yes, absolutely, and that's what we do together. But we also what we always advise for the students also at the university, because it is very important that they get contact with the outside world. I am talking constantly to my students and pushing them to do some Erasmus project. We have a very nice project in Europe for study abroad, and I think everybody should take advantage of it, because it's a very meaningful way of learning other cultures and understanding what in other places very close to us people are doing. Maybe they do the same. Maybe if we find out that they actually the same and they live in the same way, but there's always something different. A little bit. It can be in the way they eat. It can be in the way they solve some problem. It can be in the way they are used to, I don't know, have fun or to spend their time. This is something that is part of the cultural enrichment of a student, and it can then also be turned into something that is important on the specific career of the student, being him either an architect that studies the restoration of ancient building, or I don't know, an engineer that develops new instrumentation for monitoring or for constructing, or new cars technology, anything. But I think it's very important, and students should consider very much to do this. We have personally, not personally, but I will say from our institution, University of Parme and University of Žiline, we have a very long history of collaboration, but there are also, of course, other places and other universities that are possible to visit. But I would suggest to widen our field of view and suggest the student to take this opportunity, even if they lose a little bit of time, because it's normal. When you go abroad, you get a little lower to do the exams, because you have to find the language, to find everything. So you get a little maybe you get to spend a little time more than what we would do in your own country. But be sure you will learn much more than what you are losing in terms of time.
Yes. I can confirm, and in the end, we can send a message that study civil engineering and structural engineering and related topics are still very demanded in the country, in the industry, because new materials, new technology, new way of living, our new living styles are pushing these limits to the limits, and there is a still big place for innovation
and improvement.
And improvement. So civil engineering is like a role of engineering which changed not only civil engineering structures, but also whole environment for better. And there is a strong relation with environmental tasks. So civil engineering will change environment for better to be more environmentally accepted and not destroyed our living space.
Yes, absolutely. Not to forget
Yes.
that we also have to face something else, that it is the meteorological change that we are and especially with natural hazard and so therefore with the civil engineering structure, we need to face that. We have a progressively changing weather, and we know that for sure already. It's scientifically recognized that we have this changing, and we need to improve also to be able to to keep up with this modifications that we are actually facing in the future. Okay.
So thank you, Professor Segalinym, for nice discussion. I think this is maybe not the last time that we are here. I want to thank Artfórum for giving us this opportunity, and good afternoon.
Thank you, and good afternoon to everybody. Thank you.